Hello student, the topic for discussion is 8254 modes of operation. As in previous lecture we have discussed 8254 programmable timer counter. Basically it is a Intel device which is used to provide timing and control functions to the microprocessor. And this Intel 8254 is a timer counter device designed to solve the common timing control problems in microcomputer system design, and it is widely used in clock driven digital circuits. Here we have the block diagram of 8254 timer and counter. It has three 16-bit counter which can count in binary as well as VCD number system. Each counter has 3 pins: clock, gate and output, and these pins will help in modes of operations of 8254 timer and counter. Clock pin will provide the operating frequency to the counter. Gate input will be used to control the time counter in various modes, and output signal at this pin, the output of counter will be produced, and each counter has 3 individual pins, control pins. So now we can study the various mode of operations 8254. 8254 programmable timer and counter can work in 6 modes: mode 0, mode 1, mode 2, mode 3, mode 4, mode 5, and each mode functions with the clock input, gate control signal and output signal. Here we start with mode 0, that is interrupt on terminal count mode. Basically it is used for time event counting. In mode 0 operation, when a count value is loaded in the in a counter, it start counting, and the counter starts decrementing the count value by 1 for each clock pulse. And for this mode, gate input signal should be high. So as we can see here, once the n count value is loaded into the count register of counter, the counter start counting, and initially the output is high and go low for next count. So suppose count of 7 is loaded into the count register, then the output will go low for the next 7 clock periods. So once the value is loaded, and the counter will start from the next clock pulse. So here you can see the 7 is loaded into the register, then it will start from the next clock pulse and the output will go low for the next clock period and will remain high until a new count value is loaded into the counter. So next mode is mode 1, hardware retriggerable one-shot mode. In mode 1, counter functions as retriggerable monostable multi-vibrator one-shot device. In mode 1, the output will be initially high and gate pin will act as a trigger. So it will start the count process. So as you can see here, once the count value is loaded into the register and if G pin is high, once G pin is high, then the output will go low for the next count, for the next n clock periods. So as you can see here, the count of 5 is loaded and G is high. So next 5 clock periods the output will be low. If G becomes 0, the output will become high. if here, as you can see by dotted lines, if G becomes 1 here, G triggers, so the output will go low for the next n clock periods, in this case 5 clock periods. So if G does not triggers here, G remains low, so output will remain at high logic. So whenever G triggers, the output will be low for n clock periods, and n will be the count loaded into count register. So it can be seen clearly here. The once G triggers, the output will go low. If does not G does not triggers, G does not at logic high, the output will remain high. Now mode 2. This is rate generator or timed interrupt generator mode. In this mode 2 is used to generate a periodic low pulse of 1 clock per period. So if the count value of n is loaded into the count register of counter, then counter will go low once in n clock periods. For example, if count of 10 is loaded into the count register, the output will be high for 9 clock periods and low for 1 clock period. So as you can see here, suppose count of 5 is loaded. So 5 means what? 4 clock periods the output will be high, and for 1 clock period output will be low. So you can see here initially output is high. The output is high for 4 clock periods and low for 1 clock period. Next, because it is periodic, so it will repeat the same sequence. Then it will high for 4 clock periods and low for 1 clock period. Next, high for 4 clock periods and low for 1 clock period, and so on. And for this mode 2, gate pin should be on high. So gate should always be on high logic. And this is periodic, so same sequence will be repeated indefinitely. Mode 3. This is square wave generator mode. In mode 3, counter generates a square wave at output pin. So the count can be even number or count can be an odd number. For even number n, the output will be high for n by 2 clock periods and low for n by 2 clock periods. If n is an odd number, then output will be high for n plus 1 by 2 clock periods and low for n minus 1 by 2 clock periods. So for example, if counter is loaded with count of 6, so the output is high for 3 clock periods and low for 3 clock periods. If the counter is programmed for count of 5, the output is high for 3 clock periods and low for 2 clock periods. So we can see here in timing diagram of this mode. So initially the output is high and count of 6 is loaded. So 6 means what? High for 3 clock periods and low for 3 clock periods. So output is high for 3 clock periods here and low for 3 next clock periods. And high for 3 clock periods and low for next 3 clock periods, and high, and so on. And for this mode, the gate pin should be on high. Now mode 4 is software triggered strobe mode. Basically, mode 4 is used to generate a single logic low pulse after a delay. One low clock period after a count. So in this mode, when a count value n is loaded into the counter, so output will be high for n clock periods and low for 1 clock period at n plus 1th clock pulse. So it can be used to provide delay of n clock periods, and can be used in parallel data transfer for strobe signal. Mode 4 is called software triggered strobe because the counter starts its operation once the count value is written into the count register by a software instruction. Once the count value is loaded into the count register, counter starts counting. And we can see here that a trigger with count of 8. If the count register is loaded with the count of 8, so the output will be high for 8 clock periods and low for 1 clock period. Next, high for 8 clock periods and low for 1 clock periods, and so on. And the gate output for this should be at logic high always. Mode 5, hardware triggered strobe mode, retriggerable. So in mode 5 is similar with mode 4, except that counter is initiated by a rising edge, that is low to high transition of gate signal. So in mode 4, once the count value is loaded into the count register, counter starts counting. High for n clock periods and output low for 1 clock periods. But in mode 5, once the counter is loaded, it will check the gate signal. So in mode 5, the counter will wait for a low to high transition. This is there should be a rising edge, low to high transition of gate signal after the write operation of count value by the processor. Once the processor has loaded a count value in count register, it will wait for a gate signal to be transition from low to high. So as you can see here, the counter value of 5 is loaded into the count. Once the count value is loaded here, and we have a transition of lower to high in G signal here. Here we have a G transition. After loading the register, the 8254 has a G transition, so counter will start counting. So it will be high for n count. So count is 5 here, so the output will be high for 5 clock periods and 1 low for 1 clock period. But here we have G continuously at logic 1, no transition in G, so G signal, so the output will remain high. No counter will not count here, because it should for counting it should have a transition of G signal from low to high. So once here we don't have any rising edge of G signal, we don't have any transition in G signal, so output will remain high. So we have discussed all the modes, and we can compare the each mode here. Thank you.